All right, Harmony Science Academy Honors Geometry students, let's go ahead and get into date 4.5. The name of the learning topic or the lesson itself is Trig. Okay, we're going to conclude our study in Trig. As an honors class, we've really come a long way, exploring trigonometry already for a couple of weeks. And now, okay, we're going to find angle theta. So go ahead and put that in your notebooks at the very top. And as far as vocabulary, what you want to do for this portion is get on Google and type in what does inverse mean in trigonometry. Okay, some of you guys will see different things. That's fine. As long as you type this in, it should be appropriate. And go ahead and take some time to jot that in your notebooks. Okay, it'll really help you guys out. All right, so let's go ahead and talk about something really important here. Okay. Again, you guys just looked up inverse. So something that should pop to mind, okay, or something that should have come up. Let's say I have theta plus 5 equals 1 over 2. Okay? The inverse, right? Why would I want the inverse here? So I can solve for theta. The inverse of plus 5 is minus 5. Okay? So then I'd have theta equals half minus 5. Okay? Why the inverse? So I can solve for theta. What if I had 5 times theta equals half? Okay? And we're not going to have these cases, but you'll understand why I'm doing this. If you have multiply 5 times theta equals half, the inverse, right, the opposite would be to divide by 5. Okay? So we'd have, right over here, this canceled. Here we have this canceled. And theta equals half divided by 5 is 1/10. Okay? Now, I'll even go this far, right? Some of you guys can handle this, if not all. Let's say I had theta squared equals half. Okay? What would be the inverse here? Okay? If you know that the opposite of a square is square root, okay, in very simple terms, we'd have theta equals the square root of half. Okay, so this concept, right, this would cancel with this. Okay, so this concept of inverse, right, inverse operations that cancel each other, it's very powerful in all your algebra classes. So what about this case? Right, we've been dealing with sine, right, with our trigonometric identities. So this one, for example, okay, equals half. Okay, some of you guys might already know from your Google search. What would you do here to cancel out sine? Okay, well, this is new to you guys. It's actually pretty advanced, but we're going to keep it very introductory. Okay. And some of you guys from, again, the Google search should recognize this notation. Sine inverse, okay? So this is read sine inverse, and you guys will write this. Okay, maybe not experts of what it means. All you know is that it cancels sine, okay? And I did it to this side, so I have to do it to this other side. Okay, it's like a -1 exponent, but it's not a -1 exponent. Okay, it's a notation. So the sine inverse of half. So then sine inverse cancels with sine. Why the inverse? So we can solve for theta. Okay, and this we'll see in a little bit. We'll punch it in the calculator. I guess while we're here, let's go ahead and do that. Okay, or should we wait? Yeah, let's go and wait. All you care about right now for your notes is that these trigonometric identities have an inverse. Okay, there's more details to them, but we're not going to explore that. Okay, in terms of domain restrictions, we're just introducing this in general. Okay, all right. So yeah, we're going to be finding theta as our title lesson mentioned. Okay, now if it looks too advanced, it's not. Okay, we're going to keep it simple. We'll do some examples here, but before we get started, okay, let's go ahead and touch base on what we know real quick, okay? So the first thing you want to do is you want to identify theta, okay? This is for your presentations. This is for your work once you guys get started here. So take some pride. Even if they don't write theta, like if they have a question mark, you go ahead and write a theta. Immediately, I've seen a lot of you guys, the first thing you do is you identify opposite, okay? The next thing you should do is make sure, hey, do I have the hypotenuse, right? The longest side identified. So that should be, and then adjacent would be your last one, okay? All right. So, again, this is what you guys already have shown you completely understand, okay? Why? Because it helps you identify the right trigonometric identity, which is very advanced, okay? And last but not least, what else do you guys know? You guys know that when it comes to an equation, you have your trig identity, okay? Number one. You have your theta, okay? These are all bits of information that you guys know. And then you have a ratio, right? This would be the third thing, or the third component. And the fourth component is the other side, okay? So there's a lot you guys know. This is repetition, but again, it's worth it because it's information you have that's going to make this lesson just as easy as the last one, okay? All right. So here we have the worksheet you guys will be working on. Typically, I do the first couple, which helps some of these students. Let's go ahead and jump to 9 and 11, okay? That way, these can help out student at seat 9 and student seat 11, okay, moving forward. So let's go ahead and just jump into it. The first thing I'm going to do is exactly what we've been trained to do, right? Identify theta. I go opposite. All right, we've got that O with a line underneath it. The next thing I want to do is identify hypotenuse and adjacent. All right, it's good for your presentations. It's just good for your study in trigonometry, okay? Now, based on the information that's given, you guys are pretty quick now to say, okay, apparently I've been given adjacent and hypotenuse. By now, most of you guys can put that together really quickly. So that should be, you can pause the video here, but if you said cosine, good. Okay, so here's my trig identity 1, theta 2 equals adjacent over hypotenuse. Okay, and maybe what I should include here and encourage you guys to do, okay, again, since we don't do much work, the quality of your work is very important, okay? So I should go adjacent over hypotenuse to avoid even sillier mistakes, okay? Now we get to this portion, and we've got to solve for theta, but this guy's here. Now, theta is not being multiplied by cosine, okay? But this is still an operation on theta, and although it's an advanced understanding of it, all you need to know is, hey, there's something that'll cancel this, right? We can pause the video and think about it. If you said inverse cosine, good. Okay? So cosine inverse, okay, for cosine theta. What should I do here? Okay? If you're thinking do it the same thing to both sides, good. Cosine inverse. Okay? This, by design, will cancel. And we have theta equals, or in a lot of these cases, it's going to be rounding, so we'll use equivalent, and theta will equal this in the calculator, okay? So let's go ahead and pull out the calculator. Cosine inverse 38 over 55. Okay, where do I have it? Okay, now, real important, okay, you're not always in degree modes. Other people use your calculator, so let's take some notes on these steps, okay? You want to go to a scratch pad, okay? You want to press document 2, second step, hit 7, third step, and then number 2 is the fourth step, and the fifth step will be here, Okay, we have degree, so we'll leave it like that. We can cancel. Okay, and while we're here, let's go ahead and, for future reference, let's go and put that as part of your notes. So you guys find space around here, we'll list the steps here. Okay, this is for degree mode. Okay, really important. So first thing is what? Scratch sheet or scratch pad. Okay, this is nice to have. So if you're on the test and you forget, you can use your notes. The next thing we do is we hit dock. The third is we hit 7. The fourth is you hit 2. And fifth, you make sure to select degree. Okay? Alright, so it should have been in your notes last time, but this time we'll make it official. Okay? Alright. So anyways, back to our problem. We're going to take cosine inverse 38 over 55 on the calculator. So we're going to hit trigonometry. Okay. Here we have cosine and cosine inverse. It's going crazy on me. Let's see. Okay. Let me hit escape. All right. Kind of went crazy on me there. So what was it? 38 over 55. Enter. Okay. Now we have this expression here. Okay, because it's given us an exact answer, so we hit Control Enter, and it'll give us the equivalent, which is, we'll say 53.1. Okay, if this was, let's say a 5, we could say 53.2, but 53.1 will work for now. 53.1. Okay. Okay, so before we move on, just notice this is a 30, not a 33. So I just made a simple mistake that can cost me big time. So good thing I checked 38 over 55. Let's go back in here. And here we go. Trig. Cosine inverse. 38 divided by 55. Enter. Okay. This is my exact answer. We want something rounded in decimal. We got 46.3 in this case. 46.3. Alright, so that takes care of number 9. Let's go ahead and go through 11 together here really fast. Okay, let me clear some space here. And let's jump to 11. I think I said we'd do, okay? So real quick, theta, opposite. Here's the long side, hypotenuse and adjacent. Okay, so let's look at the time, see how fast I can put this together. We can have a race, see if you guys can beat me. So apparently I'm given opposite and hypotenuse. That's my sine. Right, 1, 2. It's opposite over hypotenuse. And now I just plug in sine theta. Opposite is 7 over 8. Okay. Next thing I'm going to do here, again, you guys can try and beat me here. I'm going to take sine inverse of sine theta so that it can cancel on both sides, sine inverse. Okay. And typically, this is kind of the notation. Here we'll do it this way. Okay. It's been canceled, and I have theta equals sine inverse of 7/8. So let's go to the calculator. Trigonometry, sine inverse, 7 divided by 8. Enter. There's my exact answer. I want the equivalent in decimal form, and I get 61 in this case. Okay, 61. Here's my equivalent sign, 61 degrees. All right, guys, appreciate your time. We'll catch you in class.